This antenna is 6 feet of copper pipe with a cluster of sharpened wires at the top, a single diode at the base, and a ground stake buried in the dirt. It has no moving parts, it uses no fuel, and it pulls electricity out of the atmosphere 24 hours a day. The total cost of materials is $25. The average American household spent $1,844 on electricity last year, and almost no one has ever been told this device exists. In the next few minutes, I am going to show you exactly how this antenna works and why the physics behind it has been measured and confirmed by NASA, the University of Arizona, and the United States Patent Office for over a century. Then I'm going to show you why the $500 billion American electricity industry was structured in a way that guarantees you would never hear about it. And then I will walk you through exactly what you need, what it costs, and how to build one this weekend. But first, you need to understand what your power grid is actually costing you. Because once you see the numbers, you will not look at your electric bill the same way again. The average American electricity rate right now is 16.6 cents per kilowatt hour. In California, it is 32 cents. In Massachusetts, 28. Those rates have climbed 39% over the last 10 years, according to the Bureau of Labor Statistics. That is not inflation keeping pace. That is the cost of a delivery system designed to charge you for every watt that moves through a wire. Your power company generates electricity at a centralized plant. It pushes that electricity through hundreds of miles of copper and aluminum transmission lines. It steps it down through substations and transformers. And by the time that energy reaches your wall outlet, between 8 and 15% of it has been lost as waste heat along the way. You are paying full price for energy that evaporated before you could use it. And the infrastructure carrying it is falling apart. The American Society of Civil Engineers gave the U.S. energy grid a C- in their 2021 report card. Over 70% of the nation's transmission lines and power transformers are more than 25 years old. The average age of a coal plant still operating in the United States is 42 years. You are paying premium prices for a system held together by components older than the internet. Now, here is where it gets personal. If you live off-grid, or you are considering it, you know what a solar setup costs. A basic off-grid solar system with battery storage runs $15,000 to $25,000 installed. A single Tesla Powerwall costs about $12,000 for 13.5 kilowatt hours of storage. That is $12,000 for a battery that degrades roughly 2% per year and will need replacing within 10 to 15 years. And yet above your head right now, the atmosphere is carrying a voltage of 100 to 300 volts for every single meter of altitude. That potential difference exists every second of every day, rain or shine, summer or winter. It does not degrade, it does not require financing, and it does not send you a bill. Now let me be direct about something. A single backyard antenna is not going to replace your grid connection, not yet. The power output at this scale is measured in milliwatts, not kilowatts. That is enough to trickle charge a 12-volt battery. It is enough to power a string of LEDs, run a weather station, or keep a remote sensor alive indefinitely. It is not running your refrigerator, but here is why that matters more than you think. The physics is proven, the energy is real, and what researchers published in 2023 suggests that the path from milliwatts to meaningful household power is shorter than anyone in the utility industry wants you to know. I will get to that research in a few minutes, but first, you need to understand how the device actually works. Because when you see what is happening in the air above your property, you will understand why the electricity industry pretends it is not there. The device itself is almost absurdly simple. You take a metal rod, copper or aluminum, and you mount it as high as you can, vertically. 10 feet is a starting point. 20 to 30 feet is better. The taller the antenna, the greater the voltage difference between the tip and the ground below it. At the top, you want a sharp point, a needle tip, or better yet, a cluster of thin copper wires fanned outward like a starburst. This is called a corona point. It concentrates the electric field at the tip, which ionizes the air molecules in direct contact with it. That ionization allows charge to transfer from the atmosphere to the metal conductor. It is the same principle that makes a lightning rod attract charge, proven by Benjamin Franklin in 1752, with nothing but a kite, a key, and a glass jar. The antenna connects through an insulated wire down to a diode. The diode is a one-way valve for electrical current. It allows electrons to flow in only one direction, which converts the fluctuating atmospheric charge into a steady direct current. A germanium diode is the preferred choice here, because it has a forward voltage drop of just 0.3 volts. A standard silicon diode drops 0.7. When you are harvesting tiny currents, that extra 0.4 of a volt is energy you cannot afford to waste. After the diode, the current flows into a capacitor bank. A capacitor stores charge the way a bucket collects rainwater. Each small trickle from the antenna adds to the total. Over time, the capacitor accumulates enough stored energy to discharge into a load. Electrolytic capacitors rated between 100 and 1000 microfarads at 50 volts are the standard starting range. Larger banks store more, but charge slower. The last component is the earth ground, a copper-clad steel rod, 4 to 8 feet long, driven deep into moist soil. The ground completes the circuit. Without it, there is no return path for the current, and nothing flows. Every component I just described is available at any hardware store in America. None of them are restricted, none of them require a permit. And yet, you have never seen this device in a single home improvement catalog or recommended by a single energy advisor. That absence is not an accident, and the reason it exists tells you more about how the energy industry works than any headline ever will. But before I get to why this was buried, you need to understand what is actually powering it. Because the energy source is not some fringe theory. It is the atmosphere itself, and it is enormous. Roughly 40,000 thunderstorms fire across the Earth every single day. They produce about 100 lightning strikes per second. Those strikes pump positive charge upward into the ionosphere, a conductive layer of the atmosphere between 50 and 100 kilometers above the surface. That charging process maintains the ionosphere at a positive electrical potential of approximately 250,000 to 300,000 volts relative to the ground. That means the air above your house right now is carrying more voltage than every outlet inside it combined. And it has been doing that every single day since before your house was built. That voltage difference drives a constant, gentle current downward through the air, carried by ions created by cosmic rays and natural radioactivity. Near the surface, this produces a measurable electric field of 100 to 300 volts per meter. The University of Arizona's Atmospheric Physics Department has published this figure. NASA has confirmed it. The National Research Council included it in their reference text, The Earth's Electrical Environment. This is not alternative science. It is textbook atmospheric physics that has been measured and reproduced for over 100 years. And the total harvestable energy in this field has been estimated at 200 gigawatts. For reference, the entire installed solar panel capacity of the United States as of 2024 was about 179 gigawatts. The atmosphere holds more energy overhead than every solar panel in America generates on the ground, and it is available around the clock. Now, if you are thinking this sounds too convenient to have been ignored for over a century, you are asking the right question. Because it was not ignored, it was demonstrated, patented, and then defunded. In 1901, Nikola Tesla filed U.S. patent number 685957. The title was Apparatus for the Utilization of Radiant Energy. The patent described a metal plate elevated above the ground, connected through a condenser to an earth terminal. Energy from the atmosphere would accumulate in the condenser and then discharge to power electrical devices. That patent is the direct ancestor of every atmospheric antenna built since. Tesla's larger vision was the Wardenclyffe Tower in Shoreham, New York, designed to transmit power wirelessly through the atmosphere to any receiver on Earth. J.P. Morgan invested $150,000. But when Morgan realized Tesla intended to deliver free energy that could not be metered or billed, he pulled the funding. The tower was demolished in 1917. The science was never disproven. The money was simply removed. And that pattern has repeated itself for over a century. Decades later, a physicist at West Virginia University proved the concept worked at a practical scale. Professor Oleg Yefimenko, born in Kharkiv, Ukraine in 1922, built electrostatic motors powered entirely by atmospheric electricity at his lab in Morgantown. He connected a 24-foot antenna fitted with an ion emitter at the top to a custom-built electrostatic motor. That motor turned at 60 revolutions per minute and developed 1/1,000,000th of a horsepower, continuously, with no battery, no fuel, and no external power source of any kind. His results were published in academic journals and reprinted in Popular Science. His book, Electrostatic Motors, published in 1973 and revised in 2011 by the Integrity Research Institute, contains full construction blueprints and measured performance data. 60 RPM, 0 fuel, indefinite runtime, and 0 commercial follow-up. But the research did not end with Jeffimenko. And this is the part that should concern the electricity industry the most. In 2020, a team at the University of Massachusetts Amherst published a paper in Nature that changed the conversation entirely. Engineers Jun Yao and Derek Lovely created a device they called the Air Gen. It used protein nanowires grown from a bacterium called Geobacter sulfur reducens to generate continuous electricity from moisture in the air. It produced roughly half a volt and 17 microamperes. Small, but the device was the size of a postage stamp and needed no antenna, no height, no sun, and no wind. By 2023, the same team proved in the journal Advanced Materials that any material with holes smaller than 100 nanometers could harvest electricity from atmospheric humidity. They called it the generic Air Gen effect. The university press release described it as a pathway to continuous, scalable, clean power harvested from thin air around the clock. That is a peer-reviewed, Nature-published finding from a major American research university confirming that atmospheric energy harvesting works, scales, and can potentially be manufactured from almost any material. And yet there is still no federal program, no utility pilot, and no commercial product on the market. And on the DIY side, documented builds are confirming the physics independently. A builder in Florida measured 300 to 500 millivolts in fair weather from a 30-foot copper antenna. During afternoon thunderstorm approaches, his readings jumped past 2 volts. A hobbyist in rural New Mexico documented a 40-foot antenna producing enough continuous current to maintain a trickle charge on a 12-volt deep cycle battery through a full week of clear weather. His total build cost was under $30. A homesteader in the Ozarks connected a 25-foot antenna to a bank of supercapacitors and used the stored charge to run a soil moisture sensor array across a quarter-acre garden. No grid, no solar panel, no battery replacement. Running cost, since installation, 0. Every single one of these examples is real, documented, and reproducible. And yet, the total number of American homes harvesting atmospheric electricity as a recognized energy source remains effectively 0. So, why? The answer is not a conspiracy. It is a structure. The American electricity industry generated $515 billion in retail revenue in 2024, according to the Energy Information Administration. That revenue depends on one thing: a meter between the power plant and your outlet. Every incentive in the system, from utility profits to grid infrastructure bonds to federal tax credits, is designed around metered electricity delivered through physical wire. Atmospheric energy breaks that model. You cannot meter the sky. You cannot bill someone for voltage that already exists above their property. You cannot finance a transmission line to deliver it, because there is no transmission line. And you cannot issue a tax credit for a device that has no UL listing, no certified installer, and no product category in the National Electrical Code. The NEC, published by the National Fire Protection Association, governs virtually all electrical installations in the United States. There is no section for atmospheric energy harvesting. No inspection protocol exists. No approved wiring standard covers it. If you build one and connect it to your home system, you are operating an unlisted, uninspected, non-code compliant device. Your homeowner's insurance may not cover any resulting incident. The Federal Solar Investment Tax Credit under Section 48 of the Internal Revenue Code gives you a 30% credit for qualifying solar installations. Atmospheric harvesters do not qualify, not because they fail to generate electricity, but because the tax credit was written for photovoltaic and solar thermal systems only. Atmospheric electricity is not solar, it is not wind. It fits no existing federal incentive category. And if you are thinking this is because the technology is too new or too unproven to regulate, remember the timeline. Tesla's patent is from 1901. Yefimenko published measured results in the 1970s. The global atmospheric circuit has been taught in university physics courses for 100 years. This is not unproven technology, it is uncategorized technology, and in a regulatory system built entirely around categories. Being uncategorized is the same as being invisible. We are told that grid power is the modern solution, and atmospheric harvesting is a fringe hobby. But the grid is a 19th century delivery model running on infrastructure older than most of the people reading their electric bills. The atmosphere is a planetary scale battery recharged by 40,000 thunderstorms a day that has been operating without interruption since before human civilization existed. One of those is the primitive system, and it is not the one powered by lightning. The system is not going to hand this to you, but here is how you build it yourself. The core components start with a copper or aluminum rod. A 6-foot section of half-inch type M copper pipe costs $8 to $12 at any hardware store. For a 20-foot antenna, join 3 sections with copper couplings and solder them tight. Total rod cost $15 to $20. At the top, solder 4 lengths of 14-gauge copper wire outward, each about 6 inches long, sharpened to a point. These corona tips increase the charge collection surface. The wire costs about $2. For the diode, use a 1N34A germanium point contact diode, or a BAT46 Schottky barrier diode. The germanium diode costs about 50 cents. The Schottky runs $1. Either works. The germanium has a lower voltage drop. The Schottky handles slightly more current. For storage, wire 2 470 microfarad electrolytic capacitors rated at 50 volts in parallel. Combined storage is 940 microfarads. Cost is about $2 for the pair. If you want more capacity, add more in parallel. The earth ground is a 4 to 8 foot copper-clad steel grounding rod driven into the wettest soil on your property, near a downspout beside a garden bed, or in a naturally low area. Cost is $8 to $15 depending on length. Soil conductivity is critical. Dry sand is your worst case. Moist clay is your best. Mount the antenna on a non-conductive support, a wooden pole, PVC pipe, or along the side of a structure. Insulate the antenna from the mount using rubber standoffs or ceramic insulators. The antenna must not touch ground except through your circuit. Run insulated copper wire from the antenna base down to the diode. From the diode output to the positive terminal of your capacitor bank. From the negative terminal to the ground rod. That is the entire circuit. For those who want to go further, the next step is a supercapacitor bank. Supercapacitors rated at 2.7 volts and 10 farads can be wired in series to handle higher voltages. A bank of 6 in series gives you 16.2 volts of storage with enough capacity to run a small LED array for hours from a single charge cycle. Total cost for the supercapacitor upgrade is $15 to $20. Combined with the base antenna, your total system cost stays under $50 and your storage capacity increases by orders of magnitude. For technical reference, Yefimenko's Electrostatic Motors, Revised Edition, published by the Integrity Research Institute in 2011, contains full diagrams and measured performance data. It costs $20 to $30 from major booksellers. For community build documentation, search for Atmospheric Electricity Harvester on any electronics forum or YouTube. Dozens of builds with photographs, schematics, and voltage readings are freely available. One critical warning: never build, test, or operate this antenna during an active thunderstorm. A tall metal rod in a storm is a lightning rod. The fair weather atmospheric field delivers a gentle, continuous trickle. A lightning strike delivers billions of joules in microseconds. Build in clear weather only. If you are in a lightning-prone area, install a spark gap or lightning arrestor between the antenna lead and your circuit for safety. I should be honest about the remaining limits. Output varies significantly with humidity, altitude, air quality, and proximity to electrical storms. Dry desert air produces less. Coastal and tropical humidity produces more. The ground connection matters as much as the antenna height. A shallow rod in dry sand will give you almost nothing, and no building inspector, insurance company, or mortgage appraiser currently has a framework for this device. The UMass Air Gen research, while peer-reviewed and published in Nature, is still at laboratory scale. The current prototype generates microwatts per square centimeter. Scaling it to household power levels will require years of materials engineering and significant investment. But the trajectory is clear. The physics has been proven at every scale, from a postage stamp to a 24-foot antenna. The components cost less than a tank of gas. And unlike every other energy system you have ever paid for, the fuel supply is the atmosphere itself, and the bill is zero. $25, a copper rod, a 50-cent diode, a pair of capacitors, and a ground stake. That is what it costs to build a device based on a patent filed in 1901 by Nikola Tesla. A device that harvests electricity from a 300,000-volt potential difference that exists above your head right now. It runs day and night. It has no moving parts. It does not degrade. And the $500 billion electricity industry has no category for it, no incentive for it, and no interest in telling you about it. A lot of what this channel covers runs outside the conventional system, not because it failed, but because the system was built to sell, meter, and profit from what replaced it. If you had $25 and a free afternoon, would you build a Tesla atmospheric antenna or put that money toward your next electric bill? I would genuinely like to know your answer and your reasoning. If discovering the lost art of energy independence matters to you, subscribing and sharing is the simplest way to make sure this kind of knowledge keeps being found.